This is not just another day. It's another chance for you to fulfill your dreams, to achieve all that you have ever wanted to achieve. Boom. Okay. Today we are going to be doing geometric and arithmetic series. Okay. There's a difference between a sequence and a series. A sequence is just 2, 4, 6. But a series is 2 plus 4 plus 6 plus whatever. So today we're going to look at series. Okay, so series are denoted by the term Sn, right? Sn. No, ignore that. It's just term 1. That's what Sn is equal to. S1 is equal to. But if you want to find S3, it's equal to it's equal to term 1 plus term 2 plus term 3. That's what S3 is equal to. Okay? So, if let's say you want to find Tn, right? So this is how you denote. Okay, so you'll be saying, so Tn would be equal to the sum of n minus the sum of n minus 1. That's what Tn will be equal to. So let's say, for example, we want to find T2, right? So T2 would be equal to S2, that's what n is, minus S2 minus 1, which becomes S2 minus S1. That's what T2 would be equal to. So that's how you denote it. So Sn will be working with the series today. So first we'll start with arithmetic. Okay, so this is arithmetic series. Right? Arithmetic series. So first let's just start with the general equations. The general equations, what are they? Sn is equal to n over 2 a plus l, and the other equation Sn is equal to n over 2, and we have 2a plus n minus 1 d, right? So if you look at this equation right here, it looks very similar to an equation you already know. What equation is that? The equation of the general Tn equation for arithmetic series. Arithmetic sequences, not series, sequences. So this one here is for series. So we have n, which is the number of terms. A is again the first term, and d is the common difference. But the one above, the only difference, that the letter that we don't know is L. By the way, that's an L. If you think that's any other letter, I don't know what you're reading. That's an L. Okay, so L, what does L mean? L means the last term. So you use this formula here if you know what the last term is. If they say find the 10th term, which is equal to 10, or let's say find the 9th term, which is equal to 25, you know what the last term is equal to, and you know what n is. Alright? So that's when you would use the first formula. And this is the second formula, right? The second formula is more general for like your general equations, your general series. Okay, so that we get what I'm talking about, let's do an example. Okay, so the example 1 would be, let me write both examples. So call it example A and B, right? So example A says 2 plus 4 plus 6 ... And then they say 5 plus say 20 terms, right? That's what we're going to be looking for the first example, right? Example B is going to be negative 14 minus 10 minus 6 ... And then we're going to say S of n is equal to 11520. Find n, right? These are our two examples. Okay, the first one looks pretty easy, looks pretty straightforward if you ask me. So let's get down with it, let's get to it. Okay, don't just watch me do it. Get a pad, start writing something. Okay? So, example A, right? So example A, what's the first rule when it comes to number patterns? Check what type of pattern it is. What type of series is this? Is it arithmetic? Is it geometric? We already know this is arithmetic because I told you we're working under arithmetic series. So let's check it anyways. Okay, so I'm going to say something that's going to mess with a lot of your beliefs. You don't have to be born smart or intelligent for you to do well in school. The intelligence helps, but a lot of these people that do well in school are not born intelligent. They put in the work. They work hard. When some of you are going out to party, they are out there working. Have your priorities in order. So you don't have to be born smart to do well in school. Get that into your mind. Get that into your head. So 4 minus 2. What is 4 minus 2? Gives me 2, right? 6 minus 4 gives me 2. What does that mean? The first difference is equal, so it's arithmetic. So the check is complete, right? So now we also know what D is. D is equal to 2. Because we said 6 minus 4 is equal to 2. 4 minus 2 is equal to 2. That's the first difference. So first difference, D is equal to 2, right? Next, now, what's the next thing we're going on to? Now we want to know what A is. What is A? A is equal to 2. A is the first term. The first term is equal to 2. So now let's bring in the formula. So Sn is equal to n over 2, 2a plus n minus 1 multiplied by d. Why do we use this formula here? Because I don't know what the last term is. That's why I'm using this formula here. So now let me substitute what I know. What sum of how many terms am I looking for? Sum of 20 terms. So I'm like S20 is equal to, what is n? N is equal to 20 over 2. What is A? A is the first term, it's equal to 2 plus, what is n? N is 20 minus 1. What's the common difference, which is D? It's 2, right? So now, don't do anything fancy. Just put this stuff in your calculator and you'll get a value. The value that I got was 420, right? So that's basically it. Like I said, this one is straightforward. There's nothing too complex about it. If you get the question like this in your paper, rejoice on the inside. Don't make noise in your closet, in your exam room. Okay, so let's go to B now. Example B. Okay, example B is not hard. It's not hard, it's just a little bit more testing, right? It's testing stuff that you already know, the knowledge and logic that you already know, but you're just applying it with a different formula. That's basically what this is. So what is example B asking us? It's saying they gave us the sum of n. Sum of n is equal to that number there. And then they say find n. So we are looking for what n is. What term is it that's equal to that sum over there? So how do we find that? Okay, let's look at it again. What's the first step? Check what type of series it is. Is it arithmetic? Is it geometric? So let's go through it. Negative 10 minus 14 is positive 4. Negative 6 minus 10 becomes 4. So what does it say? It means that the first difference is equal to 4, which is the same. So it means that it's arithmetic. So if it's arithmetic, what do? What we do is we know what D is. D is equal to 4. We just calculated it right now. What is A? A is the first term. It's equal to negative 14. The first term is equal to negative 14, right? So now what do? Let's bring the formula. Which formula do we use, 1 or 2? We use 2 because we don't know what the last term is. The only time we use this is when we know what the last term is. You should probably write these down, these formulas, so that you can use them. Okay? So now, let's write the formula. Sn is equal to n over 2, 2a plus n minus 1 multiplied by d, right? So what do we know here? We know what the sum is. We know that what Sn is. So Sn is equal to what? Let's write that down. 1520, right? Do we know what n is? No. Why? Because that's what we're looking for. So since that's what we're looking for, we'll just write it as n over 2, right? We know what A is. We know what A is. A is equal to what? It's equal to negative 14. right? Plus n, we don't know what it is. D, we know the differences. It's equal to 4, right? So now this is what we have. Alright? So, but now it looks a little bit complicated, but it really isn't. It's pretty straightforward, right? We multiply both sides by 2 because we want to get rid of this number here, that denominator over there. And then once we get rid of that denominator, what do we want to do? We want to multiply these numbers here and then multiply this into the bracket. So it becomes 4n minus 4, right? And then we want to add the like terms, the 2 times negative 14, which is negative 28, minus 4. So what do we end up with? We end up with 23040 is equal to n negative 28 plus 4n minus 4. That's what we have, right? So what now we have that, now it looks pretty straightforward to me, right? So what do we do here? We multiply, we add these two, and then we multiply into the box, into the bracket. So we multiply the n throughout. So now, and also we take this onto the other side so that we have everything onto one side. Because if we multiply this n to that 4n, it's gonna give us 4n squared. So we know that it's going to be a trinomial, right? So we have here 0 is equal to 4n squared minus 32n minus 23040, right? 4n squared minus 32n minus 23040. Okay, so that's what we have now, right? You can just put this into your calculator if you have a silver calculator, right? But I still have my old one. So you can use the quadratic. I won't write the quadratic. There's no need for me to write the quadratic. You should know it at the back of your head. You should know a quadratic formula without looking at the data sheets. Okay, so what is the answer equal to? We'll get n is equal to negative 72 and or n is equal to 80, right? If you look at these two answers, which one of them makes sense? Can I have term that's negative? Can I have negative 4 term? My negative 4th term? No, you can't. So what happens? So we discreted this one here. We don't know what that one there does not work. So this one here is not applicable. So what's the answer? N is equal to 80. So the term that is equal to that sum over there, 11520, is term 80, right? So if you want to check, just in case, so that you're not wasting your time, let's check, put this number here, term 80, into this equation before you put that in, and see what sum it gives you. If that sum it gives you is equal to that sum over there, that means you did it right, and you can move on to the next one. Okay, so now let's do geometric series, right? Because we have done arithmetic. It was straightforward, it was easy, we knocked it out the park. Next. Okay, geometric series. Okay, so geometric series are pretty much very similar to arithmetic series, except of course it's geometric. What does geometric mean? It has a common ratio, common R. So let me write down the general formulas that we'll be using for geometric series. So Sn, okay, Sn is equal to a r to the power of n minus 1 divided by r minus 1, right? That's the formula. But this formula here can only be used when r is greater than 1. So I can only use this formula here when r is greater than 1. Okay? So now there's another formula. It's the the second formula is a1 minus r to the power of n divided by 1 minus r. Okay, that's the second formula. Those are the two only formulas for geometric series, right? So since those are the formulas, so now what do we do? Let's do an example so that we understand what I'm talking about. Again, get your exam pad, follow through with me. Don't just look at me doing it. Okay, so we have 8, call it example 1, 8 plus 56 plus 392 and let's say to 10 terms, right? To 10. Okay, again, what's the first thing? Check what type of series it is. Is it geometric? Is it arithmetic? So what's the check, right? Let's multiply. Let's say 56 minus 8 gives me a number, but there's no way that number is equal to 392 minus 56. There is no way. I don't even have to calculate that. That wouldn't make sense, right? So I'm assuming that it's geometric, okay? But I'm still checking. So I would say R is equal to term 2, which is 56, divided by term 1, which is 8, right? What is that equal to? That's equal to 7. Apply to as many universities as you can. Because even those that you don't like, apply to those as well. Because the reality is, you might end up going to a university you don't like, but it's better than not doing anything. But that doesn't mean anything, right? It doesn't mean anything until I check this part here too, the second part. So if I say 392 divided by 56, what does that give me? It gives me 7. Right? It gives me 7. So it means that if those two, the ratio between those two is the same, it means that this series is geometric. So since it's geometric, we can write down the formula. But which formula do we write down? Do we write down this one here or this one here? Oh, I almost forgot to tell you. Only if R is less than 1. It would only make sense if that R is less than 1 for that formula there. So now, which formula do I use? Right? So, is R greater than 1? Yes, it is. So that's the formula that I use. If R was, let's say, -1, I would have to use that formula there. Why? Because that's the one that fits with that rule. Right? -1 would not fit there because it's not greater than 1. Right? So let's write the formula down. Sn is equal to A R n minus 1 over R minus 1. Right? What do I know? Do I know what A is? Okay, I never calculated A. A is equal to 8. Right? Because we know what the first term is. It's equal to 8. Right? So now, let's put in the things that we want to find. So we're saying sum to 10. So sum to 10 is equal to, what is A? A, we already know it's 8, right? What is R? What's the ratio? The ratio is 7. So 7 to the power of n. What is n? N is 10 minus 1, right? Over, what's R? What is R? R is 7 minus 1, right? So don't try to be fancy or clever or anything. Put this in your calculator and move on. What is the answer for this? The answer that I got from this was 3.77 times 10 to the power of 8, right? This number here, this is a very large number. Most of the time when in your exercise examples, you probably won't get a number that big. So, but if you do get a number that big, don't write it as a one whole number, right? Write it in this format here because it looks better, and of course this is what will be on the mark sheet. So whatever teacher is looking at, if they see your long number, they might be confused in what you have there, and then they mark it wrong even though it's right. So make sure that it's in this format here. Okay? So this was easy, right? So I'll see you on the next one, right? Okay. Boom.